everyone, my name is Ruvisha, ID 19DC122. Today in this presentation, I and Neeral will be discussing about Healthchain, which is a privacy protection system for medical data based on blockchain technology. So, these are the topics that we will be discussing in further presentation. We all know that today is the era of information technology, and with the widespread of application of information technology in the medical field, there is a large number of data being generated. The digitization of medical equipment and the structuralization of electronic data records are the general trends. While bringing convenience to people, the explosive growth of medical data will further promote the value of mining medical data. Obviously, finding out how to safely store such a large amount of data is problem that urgently need to be solved. To find a solution, we have studied existing research paper and we have found a feasible solution, which is health chain. So let's understand it in a brief. We can use blockchain technology to solve this problem. Health chain integrate blockchain, group signature, and asymmetric encryption to get a system for reliable medical data sharing between medical institution and patients. Also, this solution ensures highest security, privacy requirement, and proves feasibility. We will be discussing health chain in depth, but before that, let's see the existing medical data privacy protection solution. First one is de-identification. So de-identification is a traditional method to prevent someone's personal identity from being revealed. It has two methods. So first one method is a formal determination by a qualified experts, and the second is the removal of specified individual identities. The main advantages of this technique is that it intercepts attribute disclosure, and its problem is that as size and variety of data increases, the odds of re-identification increases too. Second existing system is hybrid execution. In this method, cloud computing is being used. Hybrid execution model is a model for confidentiality and privacy in cloud computing. It utilizes public clouds only for an organization's non-sensitive data and computation classified as public. The problem with it is that it does not deal with the key that is generated at public and private cloud in the map phase, and that it deals only with cloud as an adversary. Now, third method or third technique is identity based anonymization. So, it is type of information sanitization whose intent is privacy protection. In this method, the main difficulty with this technique is it involves comparing anonymization, privacy protection, and big data techniques to analyze usage data while protecting the identities. So now further presentation will done by Niral. Over to you, Niral.
Thank you, Dhruvi. Sir, I am Niral Patel, ID 19DC107. So, let's understand security requirement model, and by analyzing this model, we can conclude the functional requirements and non-functional requirements. So, in the functional requirements, data encryption, data upload, data signature, and data decryption. The first one is a data encryption. After the doctor enters the patient information and diagnosis information into the system should quickly and relatively secure encrypt each piece of data and assign a unique serial number to enable quick retrieval without decrypting the data. The second one is the data upload. After the data is encrypted, the physician should be able to upload the encrypted data to the relevant department of the medical institution where they are located through the system. The third one is a data signature. After the relevant department receives the data should be signed to incorrupted the organizational information. The fourth one is a data decryption. The authorized person should be the only person who can decrypt and obtain the complete data. Non-functional requirements. The first one is anonymity. The system should fully protect the privacy of a relevant personnel, including but not limited to the privacy of a patient, such as a medical institution information, because such information may still be used to analyze the true identity of the patient. The second one is a traceability. In order to avoid malicious act, the system should be able to trace the signal of a relevant affairs when necessary while the protecting the privacy of a person. The third one is a data integrity. The system should ensure the data is difficult to tamper with and provide efficient data integrity verification. The fourth one is a data confidentiality. Transaction in the electronic medical scene cannot be explicitly stored in the blockchain, so the system should be able to reliably encrypt the data. So moving towards the symmetric, uh, moving towards the cryptographic primitives. In this section, we briefly introduce the basic principle of the cryptographic techniques used in our proposed scheme. The first one is symmetric encryption. The symmetric encryption is an encryption algorithm where the same key needs to be used for encryption and decryption. Because of its fast encryption and decryption speed, symmetric encryption is often used when a large amount of data needs to be encrypted. In our scheme, we use a AES algorithm to encrypt the medical data. The second one is a decryption algorithm. Second one is a asymmetric encryption. So asymmetric encryption uses a two different keys for encryption and decryption. Compared with a symmetric encryption, asymmetric encryption does not have the problem of a secure key transmission and has a better security. However, the speed of encryption and decryption is reduced accordingly. The third one is a group signature. The group signature is a relatively new signature concept and it enables any member of a group to sign a message on a behalf of the group. Like other signature, the signature can be publicly verified. However, people other than the group manager cannot know which group member signed it. So the privacy of the group members is effectively protected. Okay, system design. The first one is a system transaction. So the transaction content is mainly composed of a serial number, a ciphertext, an encrypted symmetric encryption key, and a group signature. The serial number is the hash value calculated by linking the patient's name, ID number, so it has the characteristics of being difficult to crack and easy to verify. From the perspective of privacy protection, a piece of medical data can be divided into people, time, place, and events. We hide identity information through the serial number. In addition, location information is hidden in the group signature and on the group manager can know the information. Finally, the visit time, diagnosis content, and the other information are encrypted and saved. Module design. The system proposed mainly include five modules: transaction encryption, key encryption, transaction signature, chain transaction, and transaction retrieval. The first one is a transaction encryption. So when a diagnosis complete the diagnosis or a treatment of a patient, they need to enter the transaction upload page through the system. The physician needs to enter the patient's name and identity card number first. Before each transaction is published, the diagnosis gets an AES key to encrypt the transaction. In addition to order to improve the security without increasing the additional system burden, the system generates a different AES key by generating a random numbers every time. The second one is a key encryption. The group manager needs to maintain an additional key pair in which the public key is public to all for for the encryption of the AES key, and the private key is stored by the group manager. After the physician encrypts the transaction, the asymmetrically encrypted public key is used to encrypt the AES key. The third one is a transaction signature. The main feature of a group signature technology is that people other than the group manager can only verify whether the signature comes from the group. The main feature of a group signature technology is that people other than the group manager can only verify whether the signature comes from a group but not which group member specifically is signed. Therefore, based on this nature, we believe that the ciphertext does not need to include a medical institution information, but only the medical time, medical information, and so on. The information of a medical institution can be directly reflected in the group signature. The advantage of doing is that the attacker cannot obtain the medical institution information either by obtaining the signature or by cracking the ciphertext. The fourth one is a chain transaction. After a medical institution takes a certain number of transactions into the block, it will broadcast a message through a simple practical Bayesian fault tolerance consensus algorithm. After being accepted by the other nodes, the medical institution will upload the block to the blockchain. And finally, the fifth one is a transaction retrieval. After finding the targeted transaction, the group manager must first decrypt the AES key by using the asymmetric encryption private key, then decrypt the ciphertext by using the AES key, and finally decrypt the group signature by using the tracing key to obtain the identity of the signer. Therefore, only the group manager can obtain a complete transaction information, and if the attacker does not obtain all the keys, he can only obtain some data that do not have analytical value. This greatly protects the privacy of the data. So the next one is a security analysis. In this section, our scheme meets the security requirements are anonymity, traceability, data integrity, data confidentiality, and data privacy. Next. So, moving towards a conclusion, we have in this presentation we have concluded the design and present implementation of a medical data privacy protection system based on a blockchain and group signature, which can protect the privacy of a patient and a medical institution without sacrificing